So, midterm review, here is how I want you to do this. I want you to pull up this video and start watching it first, and then pull up the study guide. Main reason being, the study guide this time is just a PDF file. It is not a Canvas quiz or anything like that, so there is no thing where you enter in your questions and then look and see what your grade was. You do need to follow along with this video. I will tell you when to pause and try a question and then unpause, and I'll go over it. So, let's go ahead and get started. Number one, which best describes the solutions for the equation 5x minus 6 minus x equals 2x plus 2? So for this one, you are trying to solve that equation and figure out what x equals. Pause this video and see if you can work it out. All right, so for starters, what you have to do is combine the x's that are on the left-hand side. So 5x minus 1x would give me 4x minus 6 equals 2x plus 2. From here, I'm going to subtract 2x from both sides of the equation, which leaves me with 2x minus 6 on the left and a positive 2 on the right. From here, I'm going to add 6 to both sides of the equation, and that is going to give me 2x equals positive 8. Divide both sides by 2 to eliminate that, and I get my answer of x equals 4. So that would be B for this one. It would have been no solution if the two equations didn't make sense at the end, like if I got 4 equals 2. Infinite solutions is if the left and right side looked exactly the same. So number two, Wendy correctly solves the problem. Which fraction represents their solution? So on the bright side, it looks like some of these solutions are not fully simplified, so good news there. For number two, the only hint I will give you at first is you need to distribute 2/3 times x and 2/3 times -3 before you begin. So pause the video, see if you can do number two on your own, and unpause it when you're ready to move forward and see the answer. So like I said, you had to pause the video, and now that you've unpaused it, we're going through and solving it. So first of all, when you distribute that, you get 2/3 x and -2. Then I went ahead and found the least common denominator between 3 and 4, which was 12. Now I go ahead and add those two fractions together. So that is 9/12 plus 8/12 of x, and that is going to give me 17/12 of x minus 2 equals x. From here, although it looks strange, you are still going to just follow the same exact process as you normally would. You're going to go ahead and subtract your smaller x from both sides. So I'm going to subtract 1x from both sides. That is 1 over 1x, which is the same as saying I'm subtracting 12 over 12x. So that's really just going to leave me 17 minus 12 leaves me with 5/12 of x. Minus 2 equals x minus x would equal 0. From here, I'm going to add 2 to both sides of the equation. And that's going to give me 5/12 of x equals 2. And when I divide 5/12 to both sides of the equation, I'm really just multiplying the reciprocal. So I am doing 12/5 multiplied to both sides. 12 over 5 multiplied to both sides. That's going to cancel out this fraction completely, and I end up with 2 times 12/5. So if I were to do this and just stick a 1 under there, 2 over 1 times 12 over 5, I end up with 24 over 5, which is the answer that I would have wanted, 24/5. Yes, you are going to be expected to do this with fractions. If memory serves, only some of these types of questions are calculator active. I don't believe this one would be, so do watch out for that. Number three, which of these has exactly one solution? Pause this video, see if you can identify it. You should be able to do it without really solving any of them. Okay, so now that you've unpaused it, really quick, I'm just going to go through and say the ones that are obvious. It's definitely not going to be A. and it's also definitely not going to be D. Those two are obvious because there is one x on both sides. If I subtract x from both sides of the equation, that's going to make this either no solution or infinite solutions. Same thing's going to happen here. 5x minus 1x is going to be 4x on this side. 4x equals 4x, infinite solutions. It's going to be exactly the same as the last one. This one, I have 4x plus 1x, which would be 5x equals 1x. This one is probably going to be the answer. And if I double check over here and get rid of those parentheses here, and I do 4x minus 2x, I'm going to get 2x. And I will have a positive 2x on both sides of the equation, which means it's either going to end up as infinite or no solution. So it has to be C because C is the only one where I don't have the same value of x's on both sides of the equation. That's the shortcut for solving this type of equation. If it's asking you, if is it one, is it infinite, is it no solution, that's a quick way to tell. For number 4, they tried to make it seem like it was hard by giving you the two equations here, and then they went ahead and turned it into easy mode and gave you the graph of those equations. So if you really wanted to solve this by substitution, you could, or you can just look at the graph. And to solve systems of linear equations, pause the video, see if you can actually solve this one first, and then I'll tell you the answer. Okay, assuming you've unpaused it, uh, it should be right about here. It looks like we're at -3, +4, somewhere around there. So -3, +4 would be the answer we'd be looking for, which would be B, -3, +4. So yeah, just a friendly reminder, by the way, you can hold Control on your keyboard and then click plus, and that will zoom in, and then Control minus on your keyboard will zoom out. This will make some of these problems easier to see, especially if they have graphs. Number 5, same exact process as number 4. Pause it, see if you can identify the solution. All right, you should have unpaused it by now. The solution is going to be at -4, -7. We go 4 to the left, 7 down, and that's going to be it. -4, -7. Again, that's B. Reminder, when you have equations like this and it's asking for the solution to the system, you're looking for where do they cross. Number 6, this one is a little bit harder. It tells you these 2 points and that they represent a line. So I'm going to go ahead and connect those two. There is my line. And then I'm actually going to extend this line so it keeps going on forever, because that is what a line would do. So here's this red line. The player needs to provide another pair of points that will not intersect it. And it says that a player selects 5, -1 as the new point. So 5, -1 is located right here. There's 5, -1. So let me scroll down a bit. So it's asking which of these points would work. So I'm actually going to have to go ahead and clear this. But what I want you to do while I'm setting up this problem, pause this and see if you can identify which of these coordinates would work, meaning these lines would never cross. All right, so let's go ahead and use this graph here and just try. I'm just going to hold my mouse here and I'm going to drag this from 5, -1 to these other coordinates. So option A is at 5, -4, or -5, +4. So -5, +4, no, those lines are very clearly going to cross, so it is not going to be A. B says it is at -2, +3. So -2, +3. Now it doesn't cross yet, but you can very clearly tell that if we extend this line a bit more, it will continue and it will cross. So it's not B. C says +1, +6. So +1, +6. Now at first we would look at this line and say, oh, well, maybe this won't actually cross. But let's go ahead and extend this line all the way to the edge. And you can kind of see that line is getting closer. It's hard to tell, but for right now, it does look like that line might be getting closer. And if I drag this line out the other direction, we see that it is kind of getting farther away. We can see this distance here is changing, meaning eventually that line is going to cross, although barely. And then option D at 0, 9. At 0, 9, it's looking like that line is perfectly parallel. It does not get closer, it does not get farther. So the answer to this one would be D, which, yeah, it would be D for this one. So let's go ahead and move on to number 7, which is asking us about functions. So pause this, see if you can identify which point would be responsible for making this not a function. Okay, assuming you paused it, it's one of these two. A function means that the x-coordinate never repeats. It means that every input has exactly one output. So the x value is my input. We have a 4 here and another 4 here. That cannot happen. So we have to remove one of the coordinates that starts with a 4. So we would eliminate A. For number 8, which one represents a function? Pause this and see if you can identify number 8. All right, number 8, vertical line test. Draw a vertical line, and if it never crosses twice, it's a function. This one works, but these three, if I draw a vertical line like here, or here, or here, it'll fail, so those are not functions. And number 9, I accidentally said this one earlier. It's that every input has exactly one output. That is the phrasing that we use for identifying functions. Number 10, comparing two rates. So pause this here, read this carefully, and see if you can tell the rate of change for each of these two functions. So for this problem, we're mostly focusing on the slope, which would be 32 for this first one. And this second one at Exeter would be going from, let's see, 85 to 120, which is going to be an increase of $35 per month. So we've got $32 per month versus $35 a month. So it looks like Exeter City charges $3 more per month than FitLife. So that's going to be the answer we would go with. We don't really care whatever this 75 is. That could be the initial join-up fee. Yeah, the one-time membership fee, which this problem didn't ask about, so we don't care. For number 11, similar problem, we are asking for the difference in slopes, or the difference of rate of change, or the difference in the m value in our equation. So pause it, see if you can identify it on this one, now that we just did the one before it. Okay, assuming you paused it and did try that, for this one, we can see the slope here is just 3, positive 3. And for this one, x went up by 1, and the result went up by 5. So 1, 5, rise over run, that's 5 over 1. So the slope here is going to be 5. So the question was, what is the difference between the slopes of those two equations? And the difference in 5 and 3 is going to be 2. That's going to be our answer for this one. Moving on to number 12. Mr. Roberts is preparing a pop quiz for her math students. I think there are some typos in this question, but whatever. So they want to see if students can recognize the nonlinear function. So nonlinear just means that both sides of the table are not moving evenly. So for A, we have 5, 10, 15, 20, 5, 10, 15, 20. This is exactly the same, so that's linear. Nice straight line. For B, 4, 2, 0, negative 2, so it's counting by twos, that's fine. B is 4, 6, 8, 10. It's not following the same exact pattern, but it is following a pattern on both sides, and that's all we care about. There needs to be a pattern on both sides of the equation. There should be a constant change. For this one, 1, 2, 3, 4, okay? And on the right side, 1, 4, 9, 16. So it's C. C is not moving at a constant rate on the right side. They started counting by threes, 1 to 4, but then they added 5 instead to go from 4 to 9. And then they added 7 instead to go from 9 to 16. It's uneven. It's not moving at a constant rate, therefore it is not a good linear equation. For number 13, if this equation right here were graphed on a coordinate plane, what best describes the shape of this graph? So pause it, look at the options, and see if you know which one is going to be the answer. All right, so for this one, it is going to be a straight line. There's no exponent, no absolute value, nothing strange like that. And we know that it is going to be a straight line and it's going to be going down, so because this is a negative x. So negative x, we've been over this several times, but if you don't see a number in front of the x, you assume that the number in front of it is a 1. The slope is -1, not -2. -2 over here is the y-intercept, which is completely different. Number 14, what is the slope of this line? So pause it, take a second. All right, it really should have been it. You didn't really need to pause it, perhaps. This one is just going to be -5. It's the number that is attached to the variable when it is in y equals mx plus b form, the slope-intercept form. Number 15, what is the slope of a line containing the points -2, 7, and 3, -8? So remember, you need to find the rate of change. Rise over run, change in y over the change in x. So pause it, see if you can use that info to do number 15 on your own. All right, assuming you did pause it, what you would do, change in x, we went from -2 to +3. That is a change going up by 5. So that's the change in x. And then the change in y, we went from +7 to -8. So this one, we went down from 7 all the way down to 18. That is a change in -15. That's the change in y. So we take our rise over run, that -15, and we put it over the change in x, which is this +5. So we have -15 over 5, which that is basic division, 15 divided by 5. One of the values is negative, therefore the result is negative. It is -3 for number 15. Moving on to number 16, the slope of this line. We have practiced these problems to a sickening amount. Number 16, pause it, see if you can identify the slope of this line for number 16. All right, this one we are going down by 3 and to the right by 1. So rise over run, down 3, right 1, so that's -3 over 1, which simplifies to just -3. No, I did not plan that out for 15 and 16 to be -3. Number 17, it shows us this weird, funky looking M-shaped graph, and it asks which interval for x is the function nonlinear and increasing. So we're looking for it to not be a straight line, so this whole area from here to here is out. And we need it to be increasing. So anywhere from here all the way to the end of the graph is out. Can't be that. So linear and increasing, it looks like we have a curved line right here, so that's nonlinear. And it is kind of increasing. Looking from left to right, it is going upward. So that is between -2 and -1. And I forgot to tell you to pause and do this one. Oops. Yeah, it's going to be between -2 and -1 that this is going to be increasing and non-linear. Let's go ahead and do number 18. So number 18, this is one of those graphing stories. So I want you to read number 18, work it out, choose a graph that you think works, and then unpause the video and see if you can do the rest of it. So pause it now and work this out. This should take you like maybe 2, 3 minutes before you unpause it. So for this one, I've kind of gone ahead and sketched something out. We know he plans to visit the zoo, which is 75 miles from his home. So he leaves for the zoo and drives at a speed of 35 miles per hour for 1 hour. And then he stops at the gas station for 15 minutes. So we know he's gonna leave home, he's not quite gonna get to the zoo, and then he's gonna stop for like a short period of time. Then it says he drives at the same speed of 40 miles per hour for the next hour, and he reaches the zoo. So he drives again, but it's 40 miles per hour. So this one should be a slightly steeper line than before. And then he reaches the zoo. And then that would probably be where it would end, actually, because it doesn't say then he stayed there. So this is all the info we have. Let's see if one of our equations kind of matches this. So option A, yeah, 1 hour, he goes 40 miles, and then he stops, then he goes another hour. I mean, kind of, except to me, it doesn't look like those two lines are any steeper. The second half of that line should be more steep than the first one, so it's not going to be A. It's close, though. B looks a little bit closer. It does kind of look like maybe these lines aren't the same slope. So for this one, if I take this and I drag, oh, it's not going to let me drag that line. That's a shame. Well, to me, it looks like B would work a little bit better, but let's double check the other ones. Okay, yeah, it's definitely not going to be C, and it's definitely not going to be D because, I mean, look at them. He's going the wrong direction. So yeah, we're going to lean towards it being B, because if you look at it, it looks like B, the line gets ever so slightly steeper for that second half, which is what we want. Versus A, looking at it, like like leaning back, looking at the screen, it looks like A is actually getting less shallow for the second half, which is not what we wanted for this one. For number 19, talking about graphing, it says a rectangle is rotated and we obtain a new shape. So we're asking which statement is true about a rotation. So A says that it will be a quadrilateral but not a rectangle. Is that true? If I take a rectangle and I rotate it, is it not a rectangle anymore? Well, yeah, of course, it's still a rectangle. So A, not true. B, it's a parallelogram but not a rectangle. Again, no. A rotation does not change what the shape is. It'll still be a rectangle. C does say that it is a rectangle because the measurements of the lines, the angles, and the presence of parallel lines is preserved, and that's true. And D again tries to say it's not a rectangle, which is untrue. I forgot to tell you to pause again. Oops. Number 20, it says a sequence of transformations is applied to get a new shape. Which sequence is correct? So look at those two shapes and see if you can tell what sort of transformation would have happened to go from PQSR to the new shape. All right, assuming you're unpausing now, that's going to be a translation of some kind. If I just focus on point Q, for example, it looks like point Q moved uh, maybe 2 or 3 units to the right and then 1 unit down. And if we look at our answer choices, yeah, here it is. It was translated 2 units right and 1 unit down. Basically, they clicked and dragged this shape 2 units to the right and 1 unit down for all four coordinates. A rotation, it would have wound up way down here. Reflection, it would have wound up also somewhere down here. And a dilation, the shape would have shrunk or grown. So it's definitely not those three. Number 21, once again, a rotation. It says they are taking this shape and rotating it 90 degrees clockwise. So what this is going to look like is they are taking that shape and they are turning it 90 degrees clockwise, meaning this rectangle is now going to exist like that. Same shape, but they took it and they just kind of rotated it. They spun it around. Somebody like held down their finger right here on the corner and they spun the rectangle downward. And let's just double check and see which of those match up. A is a perfect match. 2 over and 4 down, perfect. B or D is close, but you can see the rectangle is orientated the wrong way. D would be an example of what would happen if you had reflected that shape, not a rotation. For number 22, this is very clearly a dilation of some kind. We can see that because the shape has now shrunk. And because it shrunk, we know that the dilation is going to be a fraction. So pause this and see if you can do this on your own. Okay, so for this, we went from LMN, so this big shape, to this small one. Let's double check, see what we can cross out. We can already eliminate that it's not going to be B, it's not going to be D, because we know this shape is shrinking. So the scale factor is going to be a fraction. It has to be less than 1 for this to shrink. So when we look, we don't have to work it out, but we know it's going to be 1/3. We just have to see which axis are we rotating or are we reflecting this shape over. And it looks like we reflected over the x-axis. So this is a reflection over the x-axis. They took the shape and flipped it over the x, and then they applied a scale factor of 1/3. Just to help you out on a future problem, a scale factor of 1/3 means they are taking the coordinates of this letter n and they are multiplying the x and y coordinate by 1/3. That's what a scale factor does, is it's multiplying the coordinates by whatever that number is. So reflect across the x and then scale factor of 1/3. For number 23, pause this, read it, because I just said something like this for one of the previous problems. So pause it and unpause it and see how this one is. All right, so it's going to be a dilation. A dilation is the only one that creates an image that is similar but is not congruent, a shape that is not exactly the same. And that's what this is. These two triangles are similar, but they are not exactly the same because the dilation changed the dimensions. So that's what that means. And on to the last couple of problems, angle problems. What is the measurement of angle x? And they tell us that this angle right over here is 22 degrees, and it shows us this supplementary angle over here is going to be x. Well, we can see this angle over here, 22 degrees, is the same as this one down here. Okay, these two angles, exactly the same. And that means this is 22 degrees, and these two are going to form a straight line. So I can really just do 180 minus 22, and that's going to give me the value of x, which is going to be 158 for this one. All right, so 158 for number 24. I forgot to tell you to pause and do that on your own. I'm sorry. I forgot again. Curses. For number 25, this one asks for the measurement of angle 1. So the measurement of angle 1, we take basically the same exact problem as before. We have this angle here, and we have this angle here. Well, we can already see that first angle over here, angle 70, that is the same. I should have chosen a different color. I thought this was a brighter color green. These angles right here, they're the same. They're both 70. So once again, we have 70 degrees combined with angle 1 would give me 180 degrees. So I just do 180 minus 70. And my answer for number 25, I forgot to tell you to pause to do this one on your own again. Too late, is 110. So number 25, the correct answer would be 110. So now that we have reached the end, now that you are finished, hooray, you know how you did. All of these questions are very likely to be on the midterm. The midterm is going to be in two parts. The first day is just going to be probably 10 questions, and they will be calculator inactive. The second day that we take it, sometime next week, will be the calculator active section, and it will probably have between 15 and 20 questions. I can't say for certain which of these problems were calculator active and inactive. Off the top of my head, I don't remember. But in general, it's what we've been doing in class. So if there's been stuff we've done in class that I said no calculator for, it'll probably be no calculator on the test. That's going to do it for this. Best of luck on the midterm. Feel free to rewatch this as much as you want. And that's all.